In this video, we will introduce how color sensors work and how we can use them to control a robot. The human eye and brain perceive color in multiple ways. First, we perceive the type of color, such as red, green, or blue. Formerly, we referred to the type of color as hue. We also perceive whether what we see is rich in color or not. For instance, a vibrantly red strawberry is rich in color, while a black and white newspaper is not. We refer to the relative richness of color as saturation. Finally, we perceive how bright a color is. Neon colors are very bright, while muted colors such as dark green leaves are not. Formally, we refer to the level of brightness as value. So a complete numeric description of color involves three numbers: hue, the color in the color wheel; saturation, the degree of colorfulness; and value, the brightness level. We abbreviate these as HSV. Most color sensors measure light in terms of intensity of three colors: red, green, and blue, abbreviated RGB. Together, these three values give us the information we need about a color, but in a different way than hue, saturation, and value. Hue, saturation, and value, or HSV, can be visualized together as a cone with hue, the circle at the top, saturation, the distance from the center, and value, the distance from the bottom. Let's take a closer look at hue. It is usually measured as an angle from 0 to 360 degrees. Now let's look at saturation. Saturation is the degree of colorfulness ranging from 0 to 1. 0 represents no color, while 1 represents a lot of color. Notice that a saturation of 0 will result in a color between white and black, depending on value. Now let's look at value. Value determines the brightness of the color and also ranges from 0 to 1. A value of 0 will always result in black, regardless of hue or saturation. A value of 1 corresponds to a bright white, a bright pastel, or a vibrant color, depending on the saturation level. Let's focus on the top of the color cone, which is the color wheel. Notice that red is covered by hue values from around 340 to 20 degrees, green from 100 to 140, and blue 210 to 275. Distinguishing color on a robot is often easier using hue rather than the three RGB colors. For example, if we were looking for yellow using RGB, we would have to check for a variety of combinations of red and green. If we use HSV instead, we can detect yellow as a range of hue values between 40 and 70. In part 2 of this video, we'll create an autonomous op mode that drives a robot forward until it reaches a blue line.